In today's lecture, we'll be seeing about TCP/IP protocol suite. This TCP/IP protocol is the protocol that is used in Internet. This TCP/IP protocol was developed prior to the OSI model. Therefore, the layers in the TCP/IP protocol suite do not exactly match with the layers in the OSI model. The original TCP/IP protocol suite was defined as four software layers built upon the hardware. However, TCP/IP is thought of a five-layer model with layers named similar to the ones in the OSI model. TCP/IP protocol suite, it has five layers starting from the bottom, the physical layer, the network access layer, the internet layer, the transport layer, and the application layer. Actually, TCP/IP reference model was built on its protocol, and that is why that reference model is only for TCP/IP protocol suite. Whereas OSI model or OSI layers, each layer defines different functions. Whereas in TCP/IP protocol, each layers, different types of protocols are defined. That we'll see in the later slides. Coming to addressing, to route a packet from one node to another node in the internet, four addresses are required. One is the application specific address, the other one is the port address, the logical address, and the physical address. The users, they communicate only with the application layer. So the data that is generated in the application layer, to that data, this application specific address is added. When this data moves to the transport layer, port address is added. Port address is 16-bit and it specifies a particular application. Then when the packet is forwarded from the transport layer to the network layer, logical address is added, which is nothing but your IP address, which is 32-bit address, and it is represented in dotted decimal notation. Then the data from the network layer, when it passes on to the data link layer, physical address is added. This physical address is a 48-bit physical address which comes along with the Ethernet card. And this physical address, the other name, you called it as MAC address. And from the data link layer, the data go to the physical layer. And here it is converted into bits. And then the real transmission takes place through the physical layer. Now, the different names that are assigned in different layers are, in the application layer, you call the data as message. In the transport layer, you call them as segments. In the network layer, you call them as datagram. And in the data link layer, you call them as frames. This physical address, as I told you, it is always other name is the MAC address. It is otherwise called as link address also. It is included in the frame used by the data link layer. It is the lowest level address. The size and format of these addresses, they vary depending on the network. For example, Ethernet uses a 6-byte physical address that is imprinted on the network interfacing card, or you call it as an Ethernet card. So this physical address, it is represented in hexadecimal notation. You can see this, and it is, the size is 6 bytes. This physical address can either be unicast, can support either unicast, multicast, or broadcasting. Some networks support all the three addresses. Coming to logical address, as I told you, logical address, the other name is the IP address. Why the reason why we need logical addresses, physical addresses, they are not adequate in an entire network environment where different networks have different address formats. A universal addressing system is needed in which every host can be identified uniquely regardless of the underlying physical network. The logical addresses are designed for this purpose. Now coming to the protocol suite of TCP/IP, as I told you that you have the physical layer, data link layer, the network layer, the transport layer, and the application layer. Physical layer and data link layer specifies the underlying LAN or WAN technology. For example, physical layer defines functions like encoding, the interface that has to be used, type tells you the types of topology, how it is going to be connected in the network, tells you about the segmentation, all that. And coming to the data link layer takes care of two important functions. One is the error control and framing and flow control. So on top of the data link layer, we have the network layer. So different protocols are defined in the network layer. So the network layer protocols are IP, Internet Protocol, Address Resolution Protocol, ICMP, Internet Control Message Protocol, and IGMP, Internet Group Management Protocol. This ARP, Address Resolution Protocol, is mainly used to map or translate IP address to physical address. This IP address is a very important address because with using this IP address, the data are going to be forwarded. ICMP is nothing but whenever an error message is generated in the network, this error message is intimated to the source node using this ICMP message. Coming to this IGMP, to the Internet Group Management Protocol, is mainly used for multicasting purpose. This ICMP has got two types of messages. One is the error message, the other one is the query message. Now, on top of the network layer, we have the transport layer. In the transport layer, the two important protocols are TCP, Transmission Control Protocol, and UDP, User Datagram Protocol. The main difference between TCP and UDP is then TCP is a connection-oriented protocol and UDP is a connectionless protocol. So, for reliable transmission, we need TCP. And IP is a connectionless protocol. That is why this TCP, which is a connection oriented protocol, is combined with IP and then used in the internet. On top of the transport layer, we have other important protocols like SMTP, Simple Mail Transfer Protocol, mainly used for mailing purpose, and for file upload and download, we use File Transfer Protocol. To connect to remote nodes, we use Telnet. And domain name system is a protocol that is used to map, uh, used to map name to addresses and address to name. And SNMP, Simple Network Management Protocol, it is mainly used for network management. And DHCP is the replacement of WoodP protocol. See, when DHCP is used, what will happen is whenever a new node comes into the network, assigning of IP address, subnet marks, the router details to which it is connected to, all these information are provided by the DHCP. So this domain name system again, it maps both IP address to name or vice versa, name to IP addresses. So using all these protocols only, a packet can be forwarded from one node to another node in the internet. Thank you.